So I'm going to do an example of what I want for project 2, and hopefully that will help you through the project, making your own polynomial and doing the things that I'm going to do to it. All right, it might take more than one video. We'll see. Okay, so make up your own polynomial function of degree 6, and I've listed an example here. And we know it has degree 6 because if we add up all the exponents, a 2, the unwritten 1 here, and the unwritten 1 here, we know that it will have degree 6. So I made up a polynomial by having either x plus or minus something in each of the parentheses. And then, of course, to get degree 6, I made sure my exponents added up to 6. Now, I could have something to the third here and something to the third here and nothing else out here, and it would be degree 6, as long as those exponents add up to 6. Now, so it's going to multiply out to have a leading term of x to the 6th. All right, so that's your first task. You make up the polynomial. Now, I've already made this example here. I'm going to use it to answer 2 and 3 and 4. So for the polynomial function that I have, I'm going to list the zeros, their multiplicities, and whether the graph will cross or touch at those zeros. So I'm going to make a little chart with zeros, multiplicities, and cross or touch. Okay, so my zeros, remember those are always the opposite of what's listed in the factor. So we have x minus 5, my 0 is a plus 5. So I have a 0 of 5. Its multiplicity is the exponent on it, so that's 2. And remember, if we have an even multiplicity, it means the graph touches at the 0, 5. All right? Now, our next one is going to give us a negative 2 as the 0. Its multiplicity is again 2. And since that's even, it touches. Our next one, opposite of the negative 4, is 4. Its multiplicity is, there's no exponents written here, so that's 1. And if the multiplicity is odd, it means it crosses the x-axis at 4. All right, and then negative 7 is our last one. Its multiplicity is the unwritten 1. And again, that's odd, so it crosses. Okay, so that's step 2. Let's look at step 3. Step 3, for the polynomial function that we've come up with, list the in behavior, the y-intercept, and the maximum number of possible turning points. Okay, in behavior, our leading term is x to the 6th. We've made it up that way. So x to the 6th is positive, and it's an even exponent. Positive and an even exponent, let's see if it'll allow me to draw, has in behavior like x squared, up on the left, up on the right. So there's our in behavior. Let's get our y-intercept. Try to turn this off. Maybe if I'm not, there we go. All right, so I'm just gonna space down here. Okay, so remember, to get a y-intercept, we have to put 0 in for x. So let's put 0 in for x through the polynomial I've made. Zero plus 2 squared. 0 minus 4, whoops, get out of the exponent there. 0 minus 4 and 0 plus 7. And let's notice, first set of parentheses, I'm going to get negative 5 squared, so that's really 25. Second set of parentheses, I'm really going to get 2 squared, so that's 4. This is just going to be negative 4. And this is going to be 7. And I am definitely going to need my calculator to multiply all that together. And I get a huge answer, but that's okay. That's going to happen when we make up our own, and we'll see that it really doesn't matter that much when we get ready to graph it. So that's negative 2,800. Okay, so we've got our y-intercept, and then the maximum number of possible turning points. Well, let's remember we made this thing up so that it had a leading term of x to the 6th. So the maximum number of turning points is always one less than our exponent, so it's 5. So max turning points is 5. Okay? All right, so now let's go to step 4. Let's graph this thing. So for most people, this is the hardest part. Let's draw. Well, I didn't mean for it to be that thick. I'm not sure why it turned from being thin to thick. Maybe I'll try to change it. We'll see. Okay, that's all right if it is. We'll still get the graph. Okay, so we look up at number 2 at our zeros. I have a 0 at 5, -2, 4, and -7. So I'm going to plot those on the x-axis. So let's see, 5 first. 1, 2, 3, 4, 5. So this is my first x-intercept. And then let's see what was next. -2. So 1, 2, -2. And then 4. There's 4 right there. And then the last one is -7. So let's see, -2, -3, -4, -5, -6, -7. All right, so there's all of my x-intercepts. Now let's use our end behavior. Our end behavior is up on the left, up on the right. So if we go to the far left, we want the graph to go up. If we go to the far right, we want this graph to go up. Okay, now let's plot the y-intercept, -2,800. Now we do not want to scale this axis. We could scale it by 100, or we could scale it by 500 if we wanted to, but really, since we're only going to put the one thing on the y-axis, we're going to say that right down here, we're going to call this our -2,800, and we're going to put it here. We're not going to put any more y values on here, so it doesn't matter that we haven't scaled it. We're just going to say it's way down here somewhere. Okay, now let's go back to our chart. We're going to look at whether our graph needs to be touching or crossing at each of its intercepts. So if we start on the leftmost intercept is -7, and it crosses. Okay, so right here at -7, it's already on this side, so it's got to cross over to this side. Now, it's got to dip down and come back up to its own intercept. Okay, so now let's look at what happens at -2. At -2, it touches, or we can think of it as bouncing. All right, so it's not going to go across the axis. It's going to bounce right here and go back down. And it's got to go back down and catch its y-intercept. And then it has to come back up to its next x-intercept. All right, so let's see what's happening at 4. At 4, it crosses. Okay, so let's cross it. So it's got to go across, and then it's going to go up and come back down to its x-intercept. Now, our graph is showing that it's bouncing or touching at 5. And of course, if we go back up here and look, yes, that's what's happening. It touches. All right, now let's check a couple of things. Let's check our turning points. We should have a maximum of 5 turning points where the graph goes from going down to going up, or from going up to going down. So let's see, here's a turning point. 1, here's 1, 2, 3, 4, 5. Okay, and there's our graph. Okay, so I don't know that I'll have time for all of the second one. We'll do part of the second one. So the next thing that you're asked to do is repeat steps 1 through 4 for a polynomial with degree 6, but with a negative leading term. And your factors have to be different than the one that we just made. Now, I made up an example, and notice how we get this negative leading term by putting a negative out in front. And again, notice that I can add up my exponents. 4 plus the unwritten 1 plus the unwritten 1 is x to the 6th. And this negative out front makes my leading term negative x to the 6th. So again, you're going to make up a bunch of factors different than mine and different than the one that you made up for your first one. And your factors will be x plus something or x minus something. All right. So now we'll repeat the same steps that we did up above. All right. So step 2 was to make our chart of the zeros, and let's see. I think I'm out of the draw feature. Okay, so let's make a chart of zeros, their multiplicity, and whether they cross or touch. All right, so first 0 from what I made up here is a positive 2. It has a multiplicity of 4. And since that's even touches. So our second 0, the opposite of the 3 is negative 3. So we'll have negative 3. The multiplicity is the unwritten 1. And remember, if the multiplicity is odd, it crosses. And then our last 0 is a 9 here. Its multiplicity is 1. And again, since that's odd, it crosses. All right, now let's go on to what we did as our next step. Back above, our next step after doing that was to list the end behavior, the Y-intercept, and the maximum number of possible turning points. All right, so the end behavior of negative x to the 6th is our upside down parabola. So if I draw my end behavior, it's an upside down parabola. Okay, so we've got our end behavior. Let's get the Y-intercept, and let's see if I can get out of the draw feature. Remember to find the Y-intercept. We're going to put 0 into our x's. So I'll have negative 0 minus 4, minus 2 to the 4th. Then we have 0 plus 3 and 0 minus 9. And again, this is probably going to be a big number, but that's okay. So I've got a negative out front. I have negative 2 to the 4th, which if you put that in the calculator, is going to give you 16. I have 3 and negative 9. And I'll multiply all of those together. That is positive 432. And then the last thing we need is the maximum number of turning points. If we look up here, our exponent was 6, so maximum turning points is going to be 1 less. It's 5. All right, now our last step is to actually draw the polynomial, but I'm running out of time on my video, so I'm going to save that for the next video.